So we're now going to look at solving linear systems by using addition properties. For addition properties, another way of looking at it is that we're going to try to eliminate one of the variables so we can isolate for one of the two variables, x or y. So the format that we're going to work in when we're doing the elimination method or using addition is to put it into standard format. When we have it in standard format, we're going to line them up like an addition statement. Now the goal is to eliminate one of the two variables. Either we eliminate the x variable or the y variable. In order to do that, we have to have a matching coefficient on both of those two terms that we're trying to eliminate. So our second step is to multiply all the terms in one of the equations by a constant so that the variables can be eliminated by having the opposite sign when we add them together. Once we add the two equations together, we solve for the remaining variable, and then we use that solution to figure out what the missing variable is. And of course, we check our solution at the end. So, for two examples, the first example, we have matching coordinates in this particular case with my x's. One is a positive 3, one is a negative 3. If I was to add 3 plus negative 3, they will eliminate the x term. The y's, we don't want them to eliminate, we want to be able to isolate and solve for them. So this one's actually set up to make you jump straight into the third step. This example over here, the 4x and 2x, they do not eliminate each other. If we were to add those two together, they would not cancel each other out right now. The 5y and the 3y, again, if we add those two together, they will not cancel one out. So this is one where we're going to have to actually use the second step. So first we're going to look at this one over here and look at how to actually set up your addition statement. Because the 3x and the negative x are opposite signs, we can just add these two equations. Now, a couple of key things here. My x terms are lined up. My y terms are lined up. The equal signs are lined up. And the constants are lined up. So, when I say add, we can only add and subtract like terms. So, 3x minus 3x will give me 0 x's. 4y plus negative 2y will give me 2y. The equal sign carries through, and then 2 plus 6 will give me 8. So key things are, 1, they have to be lined up. So if you keep them all into ax plus by equals to c format, and the two of them are lined up, everything nicely pairs with the equal sign and the addition sign or plus or minus in between. Now that we have this, we have 2y is equal to 8. Well, we want to solve for what y could be. So to both sides we're going to divide by 2, divide by 2, y is going to equal to 4. So that's part 1 of our solution. Now we have to figure out what's x, because we always need a coordinate point for our solution. Right now I have this portion for my solution, my intersection point. So if I go through and I take either one of these two equations, 3x plus 4y equals to 2, let's say, and I plug in y equals to 4, 3x plus 4 times 4 is equal to 2. You then get 3x plus 8 equal to 2, and then I'll have 3x, so I have minus 8 on each side, negative 6, and then if I divide by 3, you get x is equal to negative 2. So that is my final solution, because I've solved for both my x and my y by first eliminating one of the variables, solving for that variable, plugging it back in, and getting my second coordinate. Now if I look at the other example here, like I said, if I was just to add, nothing's going to actually eliminate. So what you can do is multiply one entire equation or two equations by a constant. So I could multiply this whole one by 2. That would then give me a 4 here. But I want them, when I add them, to cancel out. So if I multiply everything by negative 2, then I will have the following equation. The first one does not change because I have not multiplied it by any constant. Then I get negative 4x on this one, negative 2 times negative 3, positive 6y, and negative 2 times 4, negative 8. So now I've changed my addition statement to this. Again, I want to line up everything, so right now everything looks good. My y's and my x's are all lined up, my equal signs are lined up, and my constants are lined up. So 4 plus negative 4 gives me again 0x. It's going to cancel out. That's what I want. 5y plus 6y is going to give me 11y. My equal signs carry through. 2 plus negative 8, negative 6. Again, I want to solve for y, so I can divide by 11 on both sides. Y equals negative 6 over 11. So that's part of my solution again. What I now need to figure out is, what is my x value? So again, choose either one of these. 2 times x minus 3 times negative 6 over 11 equals to 4. And if I distribute 2x plus, and we'd have 18 over 11 equals to 4. And now I do 2x, and I'll have 4 minus 18 over 11. Common denominators give us 44 over 11 minus 18 over 11. So then you get 2x is going to equal 26 over 11. I want to basically divide both sides by 2. So to divide by 2, it's the same as multiplying by a half. So you're going to get x is equal to 26, which crosses out, so 13 over 11. So then, this is our final solution. It takes the isolated y when we eliminate the x, and then when we plug in the y, we get our x value here. So here's another example where we have to look at how we can multiply either one or two equations in order to cancel out one of the variables. There's two ways you can do it. Because we've got 2 and 3 here, and 4 and 5, we can't just multiply the top row by a certain number to cancel out the 3, and same thing here with the 5. What we can do is choose either to multiply this one by 3 and this one by 2, so that way both of these will become a 6x. One of these two will have to be negative. Or you can have it so that you multiply your 2x plus 4y equals to 3. We can multiply it by 5, and the 3x plus 5y is equal to 2, and we can multiply it by 4. This will then make 20y and 20y, and again, one of these two has to be positive or negative. Either way, we can do either setup. So, if we look at multiplying, let's say, by the negative 3 and the 2, we would then get negative 6x minus 12y equals to negative 9. If we multiply it by 2, we get 6x plus 10y is equal to 4. Then we can add and subtract, and it will eliminate our x terms. And again, everything is lined up. It's quite important, otherwise it won't work. If we did it this way, we'd have negative 10x minus 20y equals to negative 15. And here we'd have 12x plus 20y equal to 8. And again, when we add and subtract them, everything's lined up. Equal signs are lined up, and we work with these. So, negative 6x plus 6x, that disappears, gives us 0x, which is what we want. Negative 12y plus 10y is going to give us negative 2y, our equal sign is there. Negative 9 plus 4 is going to give us negative 5. Here, in this example, negative 10x plus 12x, we'd have positive 2x. The negative 20y and positive 20y gives me 0y equals negative 15 plus your 8 gives me negative 7. Here you can see we get negative 2y is equal to negative 5, so y is going to equal 5 over 2. Here you can see we get 2x is equal to negative 7, and again that means x is equal to negative 7 over 2. Now because I did this both ways, these two solutions here are actually my coordinate pair. I continued with this method and plugged my y into either of these two equations, I would then get my x value. If I took this guy here and I plugged it into either my two linear equations and I solved for y, I would get my 5/2. So by doing the double elimination, you can actually get the coordinate point as well.